Hello, my name is Cameron McBride, and I'm the team lead for Bowling's Rover Online Seniors, or BROS for short. On the team with me is Adam Cabanas, Clayton Davis, Quentin Guam, and Kevin Leva. And we've been working with the UTA Rover Team, who has asked us to design and fabricate a set of 6 rims and tires for their 2021 competition Rover. The requirements that the team gave us is that the wheels need to be 10 inches in diameter and no wider than 4 inches. Additionally, the wheel assembly needs to be lighter than the existing commercial off-the-shelf wheels, which are approximately 4.5 pounds. The wheels need to be able to withstand the rough terrain of the competition grounds, which is a rocky, sandy desert biome. And additionally, the team would like that the wheel assembly be cheaper than $1,000. The significance of the wheel design for the UTA Rover team is that the weight needs to be at a minimum because the Rover competition puts in a maximum weight limit of 220 pounds for the overall Rover. Additionally, in the past, the team has struggled with coming up with a unique design to supplement for the commercial off-the-shelf wheels that they've been using. And for a unique design, the team has seen issues in the past with having air in the tires because they are prone to getting flats. And other teams have also seen this issue. So we want to take an approach at a non-pneumatic tire. So process, with all the criteria in mind, we began our conceptual design phase. We started with working on the tire and the rim at the same time. We split up our team into 2 separate groups. And for the tire design, as I mentioned, we're using a non-pneumatic tire. So we took 2 different approaches. We have a hexagonal cutout and a triangular cutout. And the dimensions that you can see here in the table are the wall thicknesses. So those wall thicknesses are compatible with the rims on the right side. So for instance, a 3-inch wall thickness tire would go along with a 4-inch diameter rim. And we have 2 separate rim approaches as well, which is the weight reduced rim and the optimal design rim. The weight reduced rim is obviously lighter weight, but also was not as structurally sound, so we decided to go with the optimal design. And additionally, on the left side with the tires, we decided to go with a hexagonal cutout, as the triangular design was giving us too much deformation to where the tire would be performing like a flat tire. After we concluded our conceptual design phase, we went into structural analysis. And we were also doing this kind of alongside our conceptual design phase. So we would make a design, we would run it through ANSYS or SolidWorks and see what results we were getting. So we analyzed all of our rim and tire designs. However, I'm just picturing a couple here for you to see. The criteria that we tested it with was based on if the maximum weight of the rover was on top of one wheel. This was to give us a good idea of how strong these rims and tires would be. And as you can see here on the left, we have a factor of safety for one of our tires, which is at 94, which is extremely high, which means we have a lot of room for reducing weight. Additionally, on the right side, you can see the total deformation of a rim, which was about 9.3 times 10 to the negative 5 inches, which is really good. We don't want a lot of deformation on the rim. Now, one thing to keep in mind for the tire is that this factor of safety is extremely high right now. However, we're not going to be printing it with 100% infill. We are 3D printing these tires with TPU, so the infill is going to be slightly smaller, which is going to reduce the weight, but also reduce the factor of safety. So after our analysis phase, we entered the prototyping and test planning phase, which is the step that we're currently in right now. As of right now, we are working on experimenting with different 3D printing criteria for the tire. So as you can see here on the top right, there's a picture of a section of our tire that we printed. And we did 2 test prints like this, one at 50% and one at 10% infill. The 10% infill was giving us better deformations, so that's what we're going to be 3D printing our prototype with. However, we haven't fully finished the different settings on 3D printing. However, we have manufactured a rim, which you can see the 2 parts of the rim here. We have one centerpiece of aluminum, which is made of aluminum stock, and then we have a pipe that we purchased online, which is a 1/4-inch wall thickness aluminum pipe. Now, the aluminum sheet was CNC'd, and the pipe has been cut with a bandsaw, and the 2 were welded together to look like the image that we showed earlier. This rim is a little bit heavy. It's kind of an overcompensation so that we can test out the tire and see and make sure we're getting the results that we want. Some potential tests that we're going to be running over the winter break are a static loading just to observe deflections, a rolling test on various surfaces, preferably dirt or sand to get an idea of the traction that we're going to get from our tires. And then we're also going to be doing a point turn test, which is where the wheels on the left side and the wheels on the right side rotate in opposite directions so that the rover can turn without or with minimal translational movement. A quick recap, we are working with the UTA Rover Team to design and manufacture a set of 6 wheels for their 2021 Mars rover competition. The design process that we just went through started with a conceptual design, went into design analysis, and now into the prototyping and testing phase. During the second semester, we're going to be making further design changes based on our observations from our testing and make further weight reduction. We want to have 6 wheels assembled by mid-February. These are not finalized wheels, but they're close. This is because the rover team needs to submit a video to the competition per the requirements of the competition. And then by May of 2021, we will be delivering a finished set of 6 wheels to the UTA Rover team to use in their competition. Thank you.